The upper one is air handling unit, right? This particular is air handling unit. We commonly call AHU. You need to understand this important system like chiller and a chiller system. The chiller system and this cooling tower, they are associated with each other. But yes, the function this is at their level and chiller is at their level. So means we consider these two complete system. Yes, they are correlated, but separately the function of the cooling tower is is what we expect, and also the function of the chiller in this particularly HVAC system. And the second part and the last part of this particular block diagram is boiler. So what particular type of boiler is desired in this HVAC, that is, and then later on we are very much familiar with this terminology, pumps, and that they are the main supportive components of this particular system, and there are many measurement and control components that may not be shown over here. But yes, once we go through the understanding of these particular blocks, then is it possible, it is possible for us to apply control on that particular block, because to apply control is our part. To apply control, it is very much essential to know the system. But what are the different things that are very important in this HVAC? At first we will discuss this IBMS or intelligent building management system. What is the main function? The most common primary function of BMS to control of the building HVAC, right? Control. So this word is very important, to control. So we are actually trying to learn first the fundamental part. What we are doing first in the first few sessions, we are understanding actually what is building automation, what is BMS, you know. So we are familiar with first the system, and then once we are familiar with the system, then it is easy for us to apply the control, you know. So basically when control is applied, then we can say that it is become IBMS, intelligent building management system. So without control we can't say it is IBMS system. So yes, very important chilled water plant, that is very important part in this particular HVAC system. Then cooling towers, right now, that is also linked with this particular chilled water plant. Cooling tower is one part of this particular water plant, chilled water plant. But there are separate many functions of required to be controlled in the cooling tower also. Then condenser is also the part of chiller, that is also plays very important role in this particular HVAC system. Then heating water plant means boiler, that also plays the important role in this particular system, and exhaust systems, right? So building, when a particular building is designed and their operation is going on, so what considerations, what factors, what different things, technical things, terms we require to consider are also required to be understand first, and then we start describing the plants. Heating, ventilating, and air conditioning related to a system that perform processes designed to regulate the air conditions within the building, and air conditions within the building for comfort and safety, right? The whole idea is based on this, to provide the comfort to the occupant as well as to provide the safety. So we can't only focus on the comfortness, but parallelly, equally, we have to also focus on the safety aspect. How we can provide safety by technology, by implementing technology. So it is very interesting. Many jobs are available in this particular sector by many companies. So it is very important to have interest in this particular course. for commercial or industrial buildings. And it is not that only the commercial buildings like mall and hospitals and that are there. So many opportunities are there for the building automation. In foreign countries, what I said, individual persons are also implementing the building automation system in their particular houses, and industrial processes for or the storage of goods. And a storage of good, yes, it is very important. In Nasik West, Nasik district, we are well familiar that many agricultural products are there, produces by farmers, and it is very important to have the storage facility for that. And in that storage facility, we have to implement this building automation. Building automation is not for the big buildings and big malls and that. The applications of building automation in each and every sector, right? There are many industries by the implementing by making by that particular industry, by foundation to up to the commissioning of that building automation is implemented. Storage of goods, commercial at hospitals, malls, right? Everywhere, every aspect, this is there. HVAC systems conditions and move here to desired areas of the indoor environment. Basically, what purpose of HVAC is now we are very clear. It it provide actually the air. It will mainly focus on the air, and the air that provides the comforts. Safety part is safety part we can achieve by different types of other technological adaptation to move here to the desired areas of the indoor environment to create and maintain the desired temperature, humidity, ventilation, and air purity. So, what physical parameters are there? Yes, temperature is the most important physical parameter that we have to be considered. Then humidity is also very important parameters we have to be considered in control. Then proper ventilation, because ventilation is also very important. Many like the basements and the smoke centers and that the proper ventilation we have to, this pure air we have to provide by exhausting the unpure air. That is ventilation and air purity is also required to monitor, because in this particular system the air is taken from the atmosphere. The air is taken from the atmosphere, natural source, and then there is a treatment on that. So, is there any uncomfort parameter involved in that particular air? So, the filtering of that particular air is very essential in this particular building design and operations. So, design parameters must account for cooling load, heating load, ventilation, filtration requirements. So, it is essential to calculate the cooling load of that particular section, the heating load of that particular section, ventilation, where ventilation required, where at what stages the filtration is required. That everything is we required to think before the implementation and design of the means these things are required before implementing in the design phase. And the design means you are designing the control system for the for the HVAC, for example HVAC section. So all these things are required to be understand: cooling load, heating load, ventilation, filtration requirements. Other consideration that directly impact the HVAC system include the number of pupils in each space. So we also should, it is not blind game. We also should be focused on the number of pupils in each space. There are zones, different types of rooms and that. So that number of pupils, and based on the amount of the air delivery, the ventilation provided in that particular space is depend on the number of peoples. Interior elements like wall placements also required to be think whether they are the walls are placed in the natural air sections or they are in between anywhere. Furnishings and equipments, the furnishing also plays the role, because maybe absorption may be taken place over there, and the equipments. they are available in that particular room or that particular zone, can that equipment is sensitive this to this particular things? Because in control room or in a computer room or in a battery room, we know that the proper cooling is essential, and by maintaining such cooling, we require to be considered type of equipments over there. So all these things create the barrier to impede airflow and distribution, right now. So that's why it is very essential to consider these things in building design and operation. There are many internal loads, for example, light, requirements of light, computers, other equipments that may produce heat, humidity, right now. So light produce much heat, dissipate heat surrounding to their area. So by considering the number of lights turning on during that particular period, so how much is the requirement of the coolant, cooling air in that particular room is need to be decided based on the such type of analysis, such type of considerations. Computers room, how many computers are there, other equipments also we require to consider, because all such electronic equipments produce heat and humidity or otherwise affect ambient air conditions, right? So if we are not considering that, so ultimately there may be the lacuna taken place there, so that equally the comfort, what the target is, that comfortness and safety that is not achieved, must also be considered. If the components are selected improperly, very important, if the components are selected improperly, the HVAC system will operate inefficiently. So component selection is also very important thing. So that is directly related with the efficiency given by that component, and the durability not meet the requirements and create cost overruns. Right now, we are obviously, for the inefficiency we have to pay the cost, maybe in terms of any aspect we have to pay the cost. Special consideration, some special consideration also we require to think on that before design. Some situation require special attention with respect to HVAC system. What is that special attention? Some application have strict requirements, very strict requirement for precise temperature and humidity control. So what are that particular special applications where there is a strict requirement of precise temperature and humidity, and in that particular zone, particular section, we are required to have very high focus. These include food processing, yes, food processing part zone, maybe industry, storage of perishables, right now. Then certain industrial processes, जे नाशवंत फळे असतील, certain industrial processes, chemical processing, storage, computer rooms, greenhouses. These places are very important places in that particular plant or building or hospital. We need to have more attention, or precise type of control is required in these particular zones. So it is very important. So we have to remember this: food processing, storage of perishables, industrial processes, chemical processing and storage, computer rooms, green room. By comparing with the normal house, right now, the individual houses or in the or the malls and that. In there are some laboratory also in a particular industry or any particular type of company. In some laboratories and healthcare facilities, maybe hospitals and that, blood testing labs and all that, the potential for the migration of dangerous or infectious substances is a concern. In this case, we have to also very carefully required to give the attentions of migration of dangerous or infectious substances to other places, because this is actually carries the things, this airflow is mechanism actually carries the actually ventilate their air by providing the coolant. So obviously that carries the things from that particular section is required to give more and more attention. For example, patient recovering from surgery, that also very important. Transplants or other immunocompromised conditions are especially prone to airborne infections. You know, these airborne infections are very critical for others and may require special consideration with respect to filtration and ventilation. So obviously that particular airborne will be carried by that zone, that particular pipes and that. And so once they carry, so in that zone, it is very important to have the filtration and ventilation. So in that zone, it is very, very important to provide the filtration so that that airborne infection should not be carried to others. What are the other special consideration? For example, there is a semiconductor industrial components are manufactured over there. So in that there is a clean room of that particular semiconductor industry require very stringent filtration and control of ambient air. Here, even a small breach in contamination control could mean a loss of considerable amount of valuable product. So there is a tremendous loss if we are not giving special attention to this particular section also, that is semiconductor industry. Means it is not that we learn the building automation and now the things are over. No, it is depending on the the proposal get for what particular company or that what particular building. Based on that they are required to apply the design type of things. So once we are familiar with this, all these type of basic requirements, then it will be easy for us. Many buildings have adjacent or underground parking areas and controlling the introduction of vehicle emission. And obviously there are many vehicles over there and they obviously emit there is an emission of carbon dioxide and that into the building imperative. So in this particular section we intentionally required to implement the exhaust and that particular ventilation system. And also there is a smoking type of zones have been implemented in public buildings, restaurant and many corporate facilities. In general, proper exhaust, yes, proper exhaust and ventilation is an important concern to rid the building of unwanted contaminants. So there should not be any unwanted contaminant present over there and that should not be carried to any other place. So proper exhaust and ventilation is required to be designed in this particular section. Yes? Anything? We are going properly?
Yes, sir.
Okay.
Yes, sir.
This is theory part, so first very important part. I know that many theoretical things are there, but we need to really know these basic things. Further moving for the control and that. Another matter regarding our national interest is protecting buildings. First is this. During the construction or renovation, special attention must be paid to the HVAC system to contain and control unwanted airborne contamination. Yes, already we discussed this. But this is especially during the renovation and renovation type of things, construction and renovation. In that particular type of action, also we know that there are many unwanted airborne contamination present over there, and that should not be migrate to any other area of the building. Maintaining the negative relative pressure, yes, this is required. One type of parameter we require to control. We have to maintain the negative relative pressure in the construction area is an important consideration along with special filtration and perhaps the dedicated exhaust. So exhaust system, filtration, all these things are important to maintain the negative pressure. That is also important in this particular attention. Another matter regarding our national interest is protecting building from the infiltration of dangerous materials. So what are that dangerous material, particularly the airborne nuclear material? Right? Airborne nuclears. So airborne nuclear is of nuclear, biological or chemical. There are three types of airbornes. that seriously affects, and we require to have the special attention on these three types of airborne, that is the nuclear type of what we say the effects, biological type of effects, and the chemical type of effects, that is combinedly called NBC agents. So mainly biomedical related things, these three things are very much important in the consideration. Here, special consideration must be given to controlling and protecting the outdoor air intake. Yeah, this is possible by outdoor air intake. So we know that filtration plays the role, and the level of uncontrolled leakage and the ability of the system to purge a building means in certain cases there may be leakage, uncontrolled leakage may be taken place. So in emergency situation, it is very essential to have the purge system implemented in the building. The purging is a very important part in building automation. Finally, when we have to do this purging, so all type of contamination we have to exhaust from the building by the purging operation. This is actually very important part in any building automation. So whole building's contaminations will be exhausted out by filtering and that. So that is purging of a building. Yes, now we understand what are the important things we require to be focused on. Now, what kind of things we require to be measured? Now, what parameter actually we have to measure? Which are the different parameters that required to be measured? Some parameters, yes, temperature, humidity, moisture, all these things now we are well familiar, flow rate and that. But along with that, what specifically in building automation, what we have to be measured? And how they affect the performance in that particular section. So mainly air handling equipment is the main part. So air handler is the heart of the system, since this is where outdoor air is drawn in, right now? Outdoor air is drawn in, filtered, conditioned and mixed with the return air. So it is not only the what we can say that open loop, there is a closed loop also. So the return air is also we have to be considered from the different zones and different rooms. This supply air is then distributed through a network of ducts and from the areas of the building. So it is mainly provided through different ducts, right? It is distributed from different types of ducts from the various areas of the building. So this is what air handling equipment. What are the basic component of this air handling equipment? The basic components are dampers. So now we are going in detail now. See, there are dampers, fans, blowers, heating and cooling coils, right? Chillers, the chiller and boiler section, heating and coil, then air filters, boiler. Yes, boiler is written separately also, or furnaces. And there are different types of boilers, compressors, yes, ductwork to recover, to convey the air, and diffusers, or the registers to distribute the air evenly. So these are the basic components involved in air handling equipment. What is air handling equipment? It is the heart of that particular HVAC system. Actually, it provides the supply of air to each and every place, to different types of ducts. And which are the various components involved in this air handling unit? That are dampers, fan, blowers, etc., etc. So you can now think on that. Now all these particular components, so individually when we focus, there are many things to be required to be controlled, right, or monitored. It is not that each and everywhere the automatic control is possible. Sometimes by mechanical control, yes, that is also is possible in some of the areas. It is not that each and everywhere automatic control may be possible. But yes, these things are required to be now. These are the main blocks, and based on that, what we are actually measuring, that we will see now. So this is not actually measurement. These are the components. So now measurement of what parameter is now we are considering. A number of controlling mechanisms including thermostat, sensors and actuator. Again, the clarity is not given. It is generally generalized words are written: thermostats, sensors. Which sensor, that is not specifically mentioned, but the sensors related to all these particular components, and actuators help control the distribution of air throughout the building. So now we are coming towards a closer and closer towards the instrumentation and control. Okay. Yes, sensor, actuator, and controlling. So, for example, dampers. So in damper, what is required to be controlled? Damper positioning control. And a damper position control is important. So for that, damper positioning sensors plays the role. In a particular heating and that section or airflow system, many places there is a temperature control. So temperature control systems are we required to design. Damper position control system, temperature control system, volumetric flow control. So flow control is also very important thing. So flow control, humidity control, yes, humidity control are some of the measurement. Not here it is also not clear. It is mentioned some of the measurement parameter that should be continuously monitored, because these the parameters that are mentioned in this particular statement are some popular parameters that we always know: temperature, humidity, flow, etc. But other than that, what exact parameters are required to be controlled and considered are we now discuss in the forthcoming slides. In this air, this is the complete air handling equipment. You can see that the air is intake, and then there's a damper, so it passes through the damper, then filter, there's a pre-filter, there is a primary filter. Yes, these are the filter. Then in this particular section, the return air is mixed with this air intake, external air. Here there is a mixing take place, and then there is a fan. Again, there is a cooling coils, heating coils. The requires per requirements that they are functioning. And a cooling coil, heating coil, and then that air supply. Then that air supply goes to different types of sections through this particular dampers and that mechanism. So here, for example, this goes to zone 1, this maybe goes to zone 2, and likewise. So then here it goes, also here it goes, and the air that is remaining is again mixed with this particular section. So this is closed loop system. There are diffusers, right? So diffusers are also there. That also there is a damper over here for the diffusers. There are so many diffusers. They are placed over here, and there are different types of mechanical controls is also mentioned. There are resistance also for the particular zones. So this is generalized air handling equipment. Now we are again but now from these particular diagrams, now it is very clear that what is building automation system, what components are there in the building automation system. Now the first one what I said is air velocity. Now where air velocity is also important thing. The air velocity we require to measure. Mainly this velocity of the air is because of the fans. There are fans, distribution fans. The fans are used to introduce the air, distribute the air, and recirculate the air, and then exhaust the air. It means you can see that the function of the fan. It also introduces the air, it also distributes the air, it circulates the air, and it also exhausts the air in a particular building. So in each and every sections of this fan, there is requirement of measurement of air velocity. So obviously we are measuring velocity, or there is a continuous periodical checkup is required for the air velocity. So we are using transducers or transmitters for this particular measurement of air velocity at various points to assure that the air is being distributed as expected through the ventilation system. So air velocity is one. Measurement should be made on both the supply and return side. It is not that only in the supply side we are measuring the velocity, but also in the return side also we are required to measure the velocity. So some of the actual names are measured. It is not that only these names are there, but this is I get from one of the reference. Yes, the number of instrument, typically anemometers, reliably measure the air velocity and also calculate the air flow volume. Means once the velocity is getting, we know that how to convert that into flow rate and volume. Some type of some places there is a requirement of rotating vanes. Okay, rotating vanes for the measurement of air velocity, that measure the air speed based on how fast moving air is turns a small windmill like device. So rotating vanes, where the rotating vanes are used, they actually measure the air speed, and on what base? On the base of how fast the moving air turns a small windmill like a device. Other type of measurement is thermal anemometer. Thermal type of anemometer is somewhere used. Technology that employ hot wires, that employs hot wires or thermistors. Basic sensor is thermistor or hot wire, and it becomes thermal anemometer. That compares small changes in resistance and display it as an air velocity measurement. So small change in temperature is change in resistance to that measure resistance. Indirect actually change in resistance is converted into temperature and display it as an air velocity measurement. So this is air velocity. So common things are we know temperature, humidity, and now these are the some of the additional things. Ventilation. Ventilation refers to the amount of fresh air supplied throughout the building. So in this ventilation concept is also clear. It is amount of fresh air supplied. So amount of fresh air supplied throughout the building is a ventilation. In the interest of energy conservation, air is typically recirculated and mixed with some amount of fresh air at the air end. So yes, obviously we have to utilize this return air for the conservation, energy conservation. We use that in the air handling. We have seen in the previous diagram also. ASHRAE. ASHRAE is a standard. ASHRAE standard, or there is a full form I have mentioned over here. American Society of Heating, Refrigeration and Air Conditioning Engineers. So this is ASHRAE, is the society that is looking over the standards for this building automation, particularly in the building automation. So ASHRAE standard 62 offers detailed recommendations pertaining to ventilation in the occupied space. So more means small things are mentioned by the different societies. So they also mention what type of ventilation requirements in a particular sections is detailed is mentioned in this particular book of standard. Measurement need to be made in all occupied spaces. So now where we measure the things for the ventilation. So measurement need to be made in all occupied spaces within the building, not only in a particular building. So in all the occupied spaces within the building, we have to measure the ventilation. It is important to remember that in building with multiple air handling system, each system must be evaluated separately. So for one air handling unit, some zones are there. For another air handling unit, there may be another zones. So all the zones are required to be considered separately. A good indicator of proper ventilation in the space is the level of CO2. So now thing is that what we measure for the ventilation, and it is very important. So actually it is the measurement of CO2 level. A natural byproduct of respiration, combustion and other processes that actually have the CO2 level over there. Elevated levels means higher levels. Elevated levels of the carbon dioxide can be an indication that additional ventilation or outdoor air may be needed. So when there is some set point value, so that this is the level above the required level of CO2 in that particular area, so that is called as elevated levels of carbon dioxide. Once the controller knows, the sensors pass the indication to the controller, so suddenly it is one kind of indication that we have to take care of ventilation in that particular room in terms of outdoor air. So one rough value is mentioned over here. Indoor levels not exceed roughly 700 parts per minute. That is also mentioned for the CO2 in this indoor levels. To ensure that a building is properly ventilated, it is important to take CO2 measurements in occupied areas. Now it is very clear. Air distribution zone at varying height and compare them to outdoor levels. So continuous monitoring of the air is required, the CO2 is required in which areas? Occupied areas, air distribution zones, and also at different heights. It is not that at particular height only, at varying heights, and then compare them to the outdoor level. So this is what ventilation. So in ventilation, there is one standard associated, that is HVAC standard, and actually we measure the CO2, and their normal level is set point level is 700 ppm, and we are measuring that at occupied area air distribution zone with different heights. Then next is air volume and number of changes. There is again the air volume. Air volume is also important. In last one there was air velocity, and now here there is air volume, right? Air volume is also important. ASHRAE standard 62, now the standard is 62, recommends a certain volume of pressure be supplied to a various areas in a building, which is dependent on the number of people present and nature of activity taking place. So number of people present in that particular area of a building, and also the nature of activity taking place, whether that activity plays the important role, means what type of activity is taking place over there. So these two things decide the volume of pressure. This is typically expressed in cubic feet per minute. Different units are mentioned in different ways. Cubic meter per hour, maybe liter of air per minute per person. Okay? All these are the things for the measurement of volume of pressure. Thermal comfort. Thermal comfort we already covered by measuring the temperature, humidity, and airflow. And all these things, when we measure combinedly, that decide the comfortness in terms of thermal comfort. So what is thermal comfort actually? The perception of thermal comfort varies by individual. Thermal comfort is influenced by a combination of temperature, humidity, and airflow, and can be affected by parameters outside of the HVAC system, such as time of day. This is very critical things actually to define the value, the set point for the comfortness, because there is a different type of environment in a whole day, and what time, the time as per the, depending on the time the things are changing, we know very well, the activity level, the clothing, the number of individuals in a space, and other factors. So you can see that to implement this particular comfort, these things are required to be considered. What time of day, what set point, what type of activity is going on in that room, depending on that set point, means how many people are there, what type of clothing they have, then that also decides the another set point, and number of individuals in a space. It can be a profound impact on human concentration and productivity. So obviously comfortness is the outcome of the comfortness is the productivity and the concentration, and so that it is important in deciding the control for this particular comfortness. So ASHRAE standard 55 recommends some temperature ranges for that particular comfortness. And they decided two types of environment, summer and winter. In summer, it is expected that the temperature of the comfortness is decided between 33 degree to 28 degrees Celsius in summer, and in winter the comfortness they recommend, this is not compulsory, they recommend between 20 degrees Celsius to 25.50 degrees Celsius. So these are the things mentioned by the ASHRAE. Temperature can vary widely throughout a building, and the sensitivity to the temperature is influenced by air movement, proximity, and to the window. The sensitivity of the measurement is influenced by what? Temperature measurement is influenced by what? Movements, and air movement that influence the temperature. Proximity that influence proximity to windows means that is there any blockage in the windows, and that proximity, whether the window is open, closed, partially open, that are the things that actually influence the measurement of temperature. And obviously this type of disturbance, this is one kind of disturbance that is required to be considered in implementing the control system. So as our PLC and that are very what we can say are not robust controllers, in that disturbance may influence the control functioning to what we can say that instability, and doers, clothing, warm, and other factors. As the comfort pertains to the ventilation system, the key comfort parameter involves temperature related. Yes, now it is very clear that what parameters we are required to measure under this comfortness. That is thermal component. Temperature, relative humidity, draft, and ventilation. And measurement should be taken in all occupied areas. So complexity is much high in implementing building automation. You can imagine how much is the complexity of parameters and their areas, and there are various consideration. By looking one diagram, we can say that it is very simple. One of the parameters is airborne contaminants. Okay, that is specially related with the indoor air quality. And indoor air quality is affected by this airborne contaminant. So their measurement is also required. Correct. So many times there is a serious issue, maybe death in extreme cases, or other type of irritation to chronic problems causing many symptoms. And when final extreme case, there may be death because of the airborne contaminants. So their measurement is also very important. So mainly three types of contaminants that we require to consider are the carbon dioxide, CO, then NOx, that is nitrogen oxide, then sulfur oxide, then volatile organic compounds that are also be required to be considered. Then the particles, particularly those less than 4 microns in diameter, they are also required to be considered. Biological things like the animal parts, bacteria, viruses, and plants such as fungus, then a mold and pollen, that are also we required to consider. You can see that airborne contaminants, yes, same is there. So their analysis, that samples are required to be taken. Their analysis is required to be done. And all these things are there mentioned in this particular slide. Differential pressure is also one of the parameter that is required to be measured. It is also very important, right? Differential pressure, that one term is low differential pressure or negative pressure, high to low differential pressure. So yes, these things are also very essential in measurement point of view. Yes, differential pressure. Proper building pressure should be taken whenever renovation or reconstruction might be affect the HVAC system and alter its performance from the original design. Yes, there are different types of manometer, pressure measuring devices. You know very well what technique is used for the measurement of pressure. Maybe some manual method, maybe automatic method for the measurement of pressures. Yeah, system pressure is also there, not only differential pressure, but system pressure is also required to be considered. Yes, in that again, static pressure, velocity pressure, total pressure, all these things are there. So pressure measurement is also very important part in a particular building automation things. Air filters, yes, obviously air filters are there. Different types of examples of filters are mentioned over here. That is the media that is used in a particular filter, maybe paper, sponge, foam, spun glass, and fitted woven bags. These are the filters, types of filters and selection of filter, and that for what content, what particular year want and what type of filter. That is very important. Other filters are there. Electrostatic particles arresting type filters are also there. Electrostatic particle arresting type of filter, that is also used. Yes. So what we conclude is that the proper system design accounts for building type and size. These terms: building type and size, layout, surrounding area, the nature of activities taking place, the number of occupants, climate and other factors, making each situation distinct. A good understanding of the entire HVAC system from the outdoor air intake to the further diffuser is essential for the good management.